Let's do some code review and look at the DUSD bonds. Welcome to another DeFiChain video. My name is QG, and as always, I try to provide you with data and insights so that you can make smart decisions for yourself. Today, we will be a bit more technical than usual. It will be about the DUSD bonds. As I said, this is a thing that was developed by the community in the last weeks, and we are at the final stage before the core team will deploy it. Just a bit of a disclaimer before we start into all of this. This is, as I said, a community development. It must be deployed by the core team, and the core team did not greenlight it yet, say it this way. So they are still reviewing it, and I don't have any final feedback on it. So I don't know if they will do it exactly like I'm showing it here, but this is basically the final version of the community part of the community project that we did here. And I thought, let's do a review on it, because it's also maybe helping people to understand a bit how the smart contract development works, how the logic of the NFT works and stuff like that. And there might be the one or other part in there that helps developers and community members to do their own stuff. So let's go in. As you see here, the stuff that we talk about is this awesome DUSD bonds. We will talk about the graphic and all the stuff in a minute. First, we come to the usual cool, nice QG graphics, as everybody loves them, kind of. As a bit of a review, recap, what are DUSD bonds? DUSD bonds, as they are defined in the DFIP, I think 8 months ago or something, is the idea is we have something, a logic on the chain somewhere, where you can put in DUSD, lock them away for 1 or 2 years, and you get rewards on that locked away DUSD. With the goal to reduce the circulating supply, get the excess DUSD that we currently have out of the system, to help with the repack. And then once the pack is stable again, we likely need far more supply, because then the demand is coming back, and then those locked away DUSD can come back into the system and help produce the supply that's needed. So that's the overall idea. In the beginning, it was defined to do with lock pools with the normal liquidity mining pool rewards on the chain, because there was no other way except for a hard fork, and we didn't want to do a hard fork back then. But then we found out that that's not possible, and we switched to the idea with the MetaChain, that we say, okay, let's do it as a smart contract on the MetaChain, where we can do all that. We don't need to change the consensus on the chain, just add a smart contract. And that's when we came to the idea of the DUSD bonds. And now we have the MetaChain, and we started to do that from the community, because the core team pretty busy, and we didn't want to wait for the core team to get on that. So we wanted to give them a head start and do that from the core from the community, to say, okay, let's provide smart contract and ideas and everything, review it, and make it easy for them to implement it. And the result of that is now the DUSD bonds. We call it bonds, and first I want to give you a bit of an overview with the graphics of how it works, because there are some parts of the logic that are not 100% intuitive at the beginning, but I will try to explain why we do it like that, and what's the idea behind it. And then after the graphics and after the overview, we will also look into the code, how this thing is implemented. It's all open source. I will link the repo in the description. So if you are a developer, and if you see something now or want to take a deeper look, please go to the repo, make a comment. There is a pull request open for the final review, say it this way, where I added a few of the changes that I did during the video, because I found out a bit refactoring stuff, no major logic changes, but refactoring. And so add their commands, and then we have the final V5 version. So let's dive in. In general, the whole thing is split into two parts. It's the bond manager itself, and then we have the bonds. The bond manager is the part that takes care of the whole logic. So the user interacts with the bond manager, which is a smart contract on a MetaChain. This line is the difference between MetaChain and, as always, the native side. So be aware, it's on the MetaChain, and the user can call this lockup function where he just sends a DUSD to the bond manager. If he does that, he receives an NFT with the bond in return. This NFT represents the locked up DUSD that he did. So every time he locks up DUSD, those DUSD are locked for 1 year. So it's not one time for all lockups, but it's the period is the same for all lockups. So if someone locks it up now, he has the date, and one locks it up in 1 month. They have 1 month later the withdrawal time where they can get it back out. So that's makes it a bit more complicated in some parts, but on the other hand, that's how it's defined, and yeah, it's doable. And he receives this NFT. So this NFT is now not a JPEG on the blockchain. We also have an image for that, but it's not, the idea is not about a JPEG, it's about the data that's behind this NFT. So this NFT really represents the ownership on this special batch of the bonds. So I do a lockup, I lock up 100 USD. I now own the NFT, or the owner of this NFT, because I receive an NFT, and the owner of this NFT owns this locked up 100 USD, and is therefore also allowed to withdraw the rewards. And later, once the lockup is done, so the period is gone, it's free again, then the owner of this NFT is allowed to withdraw the funds, which also means that we allow a secondary market for the NFTs, for the bonds. So if you lock up the DUSD now, the DUSD are locked. They can't get out within the year. But you could try to sell this NFT to someone. Because if you say now, okay, I need money now, I want out of the bond, you can go to an NFT marketplace where they list, and Atlantis already provided the listing on the testnet. That's what I showed you before. And you can go there and say, okay, I have a bond, 1 year DUSD bond, 100 DUSD are locked in. You see it in the metadata and everything. And I want to sell that for 90 DUSD, for example, because I want to get out, and then therefore I need a discount, but I can sell it, you know. And if you find a buyer, they buy it. Also, maybe we reach the cap and no one else can get in, but the rewards are coming in, then maybe it gets more profitable to sell it. So maybe you can sell it above the price. So it's the secondary market, free market. But important to understand, this secondary market for the NFTs doesn't mean that the DUSD get out. They stay in. So the locked amount in the bond manager, and all the DUSD that are locked up are in the bond manager. They are locked there, and the NFTs just represent the ownership to this, and these NFTs can be transferred between the users. So that's the overall idea. Lock it in, get an NFT. And now the question is, why should I lock it in? And of course, that's the whole incentive is you get rewards like interest on those NFTs. There is no fixed reward, so it's not that you get fixed 1%, but we use the block rewards. So it depends on the amount of DUSD that are locked in and the price currently. And so how does it work? We have on the native side, we have a bot, and this bot gets this unused block rewards that we have. It's around 12 DFI per block, I think, right now. And that's the rewards that were reserved for options or something before. And we defined in the DFIP that they should now be used for these bonds as rewards. So this bot gets the DFI, uses the native DUSD DFI pool on the native side, swaps the DFI to DUSD on the native side, transfers the DUSD up to DMC, to the MetaChain, and calls add rewards on the bond manager, so it inserts the rewards to the bond manager. Also, one important thing, we have the bot that does that for the unused rewards, but the bond manager is done in a way that anybody can add rewards. So anyone who wants to incentivize and increase that could do something, make a, I don't know, a game or some other thing where they say, okay, we add rewards to the system. I don't know if anybody will do that, but just to understand the idea, anybody can insert that, and therefore it doesn't matter where this bot sits. There is no ownership of that. Anybody can send in rewards, because if you want to add rewards to the bonds, feel free. No one will stop you from that. And that's all there is to the overall idea of the bonds. Users lock up their DUSD, get an NFT as ownership certificate, basically, which they can trade then. And we have the bot that gets the unused rewards, swaps it for DUSD, and then adds the rewards to the bond manager for the rewards. Bond manager takes care of what NFT owns what DUSD, how are the rewards distributed, and all that stuff. So now let's look at this rewards distribution. So if you look at the bond manager, we have this smart contract, and within the smart contract, we have a list of all investments, which is basically just a list of an array of lists of entries with indices starting by 0 and going up to infinity. And he knows a bit of stuff. So, for example, we have here now the first three. The first one locked up 55 DUSD. He did it on 11th of January this year, so it's locked up for 1 year. Then the next one, 155, locked up till 12th of, and then a big one, 99,800 until 13th. Numbers, okay, I did those three so that we get a total value locked of 100K. Easy numbers, but in the total, the bond manager keeps track of the total value locked, the total investment that he has in there, and each entry has the numbers. One important thing to understand from the complexity wise, because it's important for the coming topics, is we don't know how big this will be. So we always have to keep in mind that we don't iterate over that and anything, because this can be a lot of entries, right? Just that's why we keep the track of the total value locked and not always iterate over all of them and sum them up, but keep the track somewhere else in the smart contract. So now this itself pretty easy. We have the reference, the NFT goes out, and we know NFT number 0 has 55, number 1 has 145. If someone trades that, moves the NFT ownership around, we don't care, because as soon as someone comes along and says, look, that's my NFT, I want to do something with that, we can check the data and everything. Now the only thing that's kind of interesting, or where there's a bit of logic involved that we need to explain, in my opinion, is the rewards distribution. Because how does it work? We have internally rewards per deposit. So to say, okay, if you look at the total value locked, we have in total a deposits of 100,000, and right now no rewards came in, so there's the rewards per deposit are 0 DUSD per deposit. No rewards per deposit. All the investments have no rewards per deposit. And they start with that on the beginning. And now new rewards come in. Someone sends in 1,000 DUSD as reward. All just random numbers, or numbers so it's easier to calculate with. But 1,000 DUSD get in. So based on the total value locked, we now have 1%, so 0.001 DUSD per deposit. So per DUSD in a deposit, 1 cent is reward. Now, one option to keep track of all that stuff, because the investments might change, new investments, new batches might come in. So we need to keep track of that, right? So one way would be to say, okay, we take that and we distribute it and give everyone in here, or update all those entries and give everyone the according rewards per deposit that he has, and says, okay, you get 55 cents, you get 145 and stuff like that, and sum it up. But that means we would need to iterate over all the investments. And as I said before, it could be a lot, and in Solidity, in the smart contract world, you can't do crazy amount of computations because you have a gas limit on the block. It's not only about you don't want to pay that much fees, it's also that you have a limit of computations that you can do in one block. And if you can't do it in one block, it gets complicated that it's still consistent and everything across multiple transactions, right? So we can't just say iterate through all of them and update the numbers, because I think we did it in the first version. I did it in the first version because I was also pretty new to this. But thanks to, I think, throu hub on GitHub, came up with the idea, or showed me the way how to do that in a more efficient way. And back then I tested it, and it was like you can do 500 investments basically in one block or in one transaction, and then you have to split it up, and we hope or expect to have more than 500 lockups, so we definitely need to take care of it. And the way that it's done is pretty smart, but in the beginning not intuitive, say it this way. Once you understand it, it's intuitive. So let's talk about it. The bond manager itself keeps track of this rewards per deposit. This rewards per deposit is a number that only goes up, so it only increases. And it means overall, in total, since the beginning, we had that amount of rewards per deposit. So right now we added that and we now have on that deposit. If we now get a new batch of rewards in, we increase that and say, okay, how much is it now per deposit, the rewards, and add that. But we'll come to that. Right now, in the beginning, we save that number and we save the reference where this investment was created. All those investments were created when there was no reward at all. So this number was 0. That's why it has 0 here. And now how you calculate it is pretty straightforward. We have as accumulated rewards per deposit of 0.01. This deposit is 145. So 145 times 0.01 is 1.45. So batch 2, it's index 1, but doesn't matter. So this batch actually has an available rewards of 1.45. We can calculate that based on this number and this whenever someone wants to know it, but we don't need to calculate it upfront for everyone, right? So it's gas efficient, because if a new rewards come in, we just say divide that by that. This is also a number is saved in the smart contract. Divide that by that and increase the rewards per deposit by that ratio. And this number only goes up, and we're done. Nothing has to be done on the add rewards. And if someone wants to withdraw claim rewards, or just know how much rewards they have or accumulated, they take that, take the deposit, take that number, sum it up, and it's done. Now, what happens and how does this change if something comes in, new investments come in and so on? So let's remove that and add the deposit. Remove that. So now another 100,000 come in. Again, to have nice numbers. 100,000 come in, so we have now 200,000 DUSD locked. And the rewards per deposit are still 0.1, because till now, this is always the summed up rewards per deposit at the time of the deposit of the reward. So what came in during the whole thing, and always at that snapshot. So this is still 0.01, and what's important now is, because this 100K have no access to the rewards that came in before it deposited. So the rewards, this come in, but this keeps track and saves in the log entry when it's created the current state of the rewards per deposit. So it starts with 0.01 DUSD per deposit. So that's the offset that it starts with. So this is not what it owned, but this is where the offset that it starts with. Which means if you now calculate this thing that we had before here, for this one, if you calculate it for this one, it's the 100k times currently 001 minus 001 here. So there is no rewards for this one, just for those. That's one. That's important to understand. Now, how do we calculate it now? Just to keep the track of the numbers, let's say another 1000 DUSD come in. Another 1000 DUSD now means we have 0.005 DUSD because 1000 divided by 200k, because we have now doubled the total value locked. So the rewards per deposit increased only by 0.005 to 1.0015. That's what I meant before with when rewards come in. The rewards per deposit is always on the current, at the state of the reward addition, the current total value locked. So this comes in, we increase that number, as I said, only increases, and that's the accumulated from everything since the beginning, 0.015. That's the number we have right now. So how would we calculate now the rewards for the batch? On the batch 2, on this one, again, as before, 145 times 0.015 is the new rewards, because this one was here since the beginning, so every time they added. So that's what was added from both reward additions. Now, this one is a bit different, so the batch 4 is different. Here we have, again, the 15, but the difference is the 0.001. So we need to take the difference between those two. So 15 minus 1, 0.005. So this one only accumulated rewards of 500 DUSD, because the 100,000 multiplied by the difference between those two is the 500. And that's now how it's distributed equally or fairly between the ones, because always when rewards come in, the rewards are on the numbers, or in theoretically from the concept, distributed across all current deposits that we have, because that's across the total value locked, but we don't have to update the investments all the time. We can do it with the calculations. The only thing that we need to keep track of is now on each log entry, if they already claimed rewards. So that's the available rewards that we calculate in total, what they would get if they have not claimed anything. And if we also now keep track of what they claimed, we can say, okay, your available rewards that you can still claim is the difference between those. And then we are done and have everything calculated without any issues with the gas limits and gas estimations. So much for the graphics. Let's look into some code. And therefore, let's switch to code. I remove my cam because you don't want to see me, you want to see the code right now. This is now the whole DUSD Bonds smart contract. There is something in there, or there's, okay, it's the logic itself is 400 lines, basically. I will not go into all the details of all the stuff, but try to cover the important things. So here at the end, I have two libraries in there, the base64 and the datetime. They are only used, and that's also important to understand, for creating the metadata and the NFT image for the NFTs. So they have no impact on the logic whatsoever. I added them and didn't reference them, so they are in because they are not 100% reference implementation somewhere. Up here, what we use, the Open Zeppelin reference implementation, which are best practice to use them. So they are just imported. If you know Solidity, if you know smart contract development, you understand all of that. If not, you don't need to right now, because I think it's pretty easy to understand without knowing what's happening here. But just that's why I will not go too deep into that one, because they are not critical regarding security or safety or anything, because those libraries you will see, they are only used in the views, so where no logic, no state is changed or anything. And yeah, they are pretty straightforward, but anyone can review them if they want anyway. Now the overall thing, as we see here, we have basically two main contracts, or two contracts at all. The one is the bond manager, as we talked before, which takes care of all the stuff. And then we have the bonds themselves, which are ERC 721s, which means they are NFTs. So that's the standard for NFTs. They are enumerable, which means that you can query the bond itself for all the bonds or all the tokens that are owned by an address. So you can ask the bond, give me all the tokens that are owned by this address, so that I can iterate over them. And that's needed for the for some functions, say it this way. And that's why we have the enumerable and it's ownable and stuff. So let's first look at the bond itself, because this is pretty straightforward and you can get stuff. I will first talk about the logic and all the stuff, and afterwards talk about the metadata. So if you're only interested in the NFT metadata, how they are done directly on the chain, skip to the other section. But now first look at the code. And code-wise or logic-wise, the bond is really, really straightforward. We have the bond manager referenced so that we can access metadata and everything. And we have the threshold for the stuff. That's all just for the meta. On the constructor, we give it a name, we give it a symbol, and we give it a manager. The manager is the owner of the NFT smart contract, because here we need to mint and burn. Because dynamically, as soon as someone locks DUSD up, we create a new NFT, and if someone withdraws the locked up DUSD, we burn this NFT. So the owner, and here only owner, based on this reference implementation from OpenZeppelin. So only the owner can call this, and they can mint and they can burn based on the reference stuff this token ID. And minting happens to the receiver. The only additional thing that we have here is that we can get the batch data from the manager, so to know what this batch has on data. It's a few. And then the other stuff is really just for the NFT metadata, and we will cover that later. So the bond itself, really just the NFT stuff and the minting and burning from the owner. Now let's look at the bond manager. Two things, it's ownable, it's got a re-entrancy guard, we'll cover that in a minute, but that's the reference. Those things, again, if you know Solidity, this is quite straightforward. We have defined some errors that can happen, and we have some events that we want to emit to the blockchain for easier statistic querying and everything. Then we come to the interesting part. As I said before, the bond manager needs to keep track of the investments. A bond entry, skipped it before, a bond entry is just a structure which keeps track of this lockup batch. So this is also what's represented by the NFT and everything with the number. So in there you have the amount that got locked up, you have the timestamp until it's locked up, you have and that's this initial rewards per deposit, this rewards per deposit that you need to save, what we talked about before, and it keeps track of how many rewards were claimed for this bond entry already. As I said before, that's the things that we need to keep track of, and that's it. Other things, that's all we need to know for one bond. And we have here this array of bond entries, we call it investments, and that's the main data of this smart contract. Additionally, we have from the beginning in the constructor, we will set the lockup period, we will set the total investment cap, because it's limited. The bonds are limited to 100 million in total over both versions, so 1 year and 2 year in total, is limited to 100 million. And we have the coin that is used in here, so that the coin that can be locked up. That's on purpose not hard-coded, because I wanted to have it usable for both testnet and mainnet with the same code, so that you don't have to change the code after testing it on testnet. And on testnet we have different smart contract address or token address for the DUSD, so it's something that you need to put in on the construction. And then the bond token, so this bond that we had before, this smart contract, this bond token is also referenced from the bond manager, because he needs to know who to ask, who's the owner of that stuff. And we have the exit criteria. If this is triggered or not, it's a simple flag. And I didn't I said that before. We have the special exit criteria or early exit criteria in the DFIP, that as soon as the algo ratio goes below 30%, the bonds are released and anyone can withdraw them before the lockup. They don't have to, but anyone can withdraw it, and that's this exit criteria. And then we also just have the states that are kept internally to say, okay, how many DUSD were added in total, how many were withdrawn already, how many total rewards did we get in, and how many total rewards got claimed, just to have that. And this important number that we had in the graphics before, the current rewards per deposit, only goes up. And also for reference, the last rewards block, that's just to keep track of the total of the APR, basically, to have a bit of a reference there. Then a bit of a syntax improvements, where we have this modifier valid batch, which just says, okay, if we add this modifier valid batch to a method, this method first checks if this batch is within the length of the investment, so it's not out of the range. If it's out of the range, revert and get out. And then we have the modifier for owned batch, which makes sure that on the one hand it's a valid batch, and on the other hand that the owner, and here we again ask the bond token, so the bond smart contract, the NFT, if the owner of this batch ID is the current sender of the transaction, and if not, then revert with this error, and otherwise continue. So that's how it's done, or how the modifiers are working. Now we look into the actual smart contract, the actual logic. Constructor, still nothing fancy here. It's owned, and the only thing where we need an owner is to trigger the exit criteria, because not everyone is allowed to trigger that. Only the owner of the bond manager is allowed to do that. So here we have the only owner again, and it just sets the exit criteria to true. So once the exit criteria is set to true, it cannot be set to false again. No way of reverting that. That's how we want it in DeFi. No bad action possible. In the constructor, we give in lock time in seconds, total cap with 18 digits, and the locked coin is the address of the DUSD token. Then first thing we do is we create our own bond token. So that's the smart contract that we saw before. We create that with the name, with the symbol added together, and this is just a reference to us, so the bond manager itself. And with this, as we saw before, the bond now has this as the owner, so it's adding itself as the owner of the bond, so that it can do the minting and the burning. Internally, it saves the lockup period, total invest cap, the coin, and the exit criteria is initialized to false. So we are ready to go. Now, here we have a bit of the views. Views mean that they are not transactions that get into the chain. It's just there to get status out or help us sometimes for the smart contract itself, like the current total value, which is total invest, everything that comes in, minus what got out, minus the withdrawal. So that's the investments that we got in. We need that for the rewards per deposit calculation later on. Then we have the get batch data, which returns this bond entry structure for a batch. As you saw before, we need that in the bond itself so that they can access the data for the metadata and everything. Then there are some small helpers to say, okay, the current TVL of this address. And here we now have this enumerable stuff. And we will use that quite a lot later on. So let's get through it with that once. Here we want total TVL of this address. So we initialize the value and say, okay, start it with 0 and then add up all the TVL in the bonds. And now we ask the bond token, give me the balance of this address. So how many tokens does this user or this address own? This is not a number, and then we can iterate from 0 to the number of tokens that he owns and ask it to say token of owner by index. So what token number is the first token of this owner? And that's this enumerable stuff that's standard from OpenZeppelin, so not our implementation. And here we get so all the token IDs from the beginning. And we make sure, we see that later in the lookup, we make sure that the token ID is exactly the index in our investments array. So we can say we iterate over all the token indexes of this owner and take the token ID, get the token ID for this address, for this index, and therefore get the investments, the bond entry out. Now we know, okay, for this token ID, this bond entry data, this token ID represents this amount, added to the total value locked, and we have the total value. So this is how you iterate over all the NFTs owned by one address. Then we have also the rewards claimable, which is in total, overall, what got summed up, total rewards minus total claimed, pretty straightforward. And then we have one of the most used functions in this smart contract, which is the available rewards. And this is the number, or this is the function that tells you how much rewards are available for this batch. That's the logic that I explained before in the graphics, basically. It needs to be a valid batch, so that modifier, and then we take this bond entry from this and do this logic that we had before. What's the total rewards per deposit right now, the global one, in the overall smart contract, in the overall bond manager, minus the initial rewards per deposit that was there at the lockup of this one. As we said before, this difference, get this added rewards per deposit, the added rewards per deposit since this lockup, and now the total rewards for the funds of this batch is added rewards per deposit multiplied by the locked up funds. And this is now a bit technical because in Solidity there is no floating point operation, or there is, but yeah, we don't use it because it's not accurate or not accurate enough. So everything is done as integers with 18 digits. So 1 in the Solidity is not 1, but it's actually 1 with 18 zeros because we represent everything with the digits in zeros. So if we have now a number with 18 digits, which is the added rewards per deposit, because they are all numbers with 18 digits, and we multiply that by a number with 18 digits, we now have a number with 36 digits, because if you have only 2 digits, just as a reference, only 2 digits, you have 1 is 100, and if you multiply 100 by 100, 2 numbers with 2 digits, you suddenly have 10,000, which is a number with 4 digits. So we need to remove the additional digits. So a number with 18 digits times a number with 18 digits divided, so now we would have 36 digits, and we divide it by 18, which means we remove 18 digits again, so we're back down to 18 digits. That's why it's divided here. And that's the total rewards for funds, where we say, okay, this batch can claim in total this amount of rewards. Now, as I said before, it might have claimed rewards already. So the available rewards is the total. If the total is bigger than the already claimed rewards, it's the minus. we need this check so that we don't risk any overflow. It cannot overflow anyway because we are not allowing that the claimed rewards goes over that, but it's just better to have it like that to be on the safe side. So as long as it's bigger, we have the difference, otherwise we return 0. Now, this a few lines, core logic. If you don't understand that, maybe repeat it or rewatch it, because that's really the most important thing of the whole contract. Then we have just two helper functions that say, okay, give me all the available rewards for this address. Again, iterate over all the tokens in that address, calculate the available rewards that we have up here, sum them up, return them. Again, all withdrawable funds, iterate over all the tokens in this address and return them. As I said before, iterating over a lot of entries might run into gas issues. So that's why those helper functions are just there for convenience. If someone, because usually one address will only own 1, 2, 3, maybe 10 bonds, right? Even if it's 100, it's still fine, but there we get at the limits. So this should only be used by users with only a few tokens, and that's fine. It's no risk for the smart contract if someone has 500 investments, because then this address just should not use the overall functions, but do it batch by batch, withdraw, claim, one by one, right? So it's still possible. These are just convenience functions to say, iterate through them and tell me all my available rewards, iterate through all my withdrawable funds and add them up and stuff like that. So that's just convenience functions to not have to do that outside with a lot of requests. And then, so that's the views. All of them have the view stuff, so they don't change anything in the state. So they are just calls to the contract and not transactions that are sent there. And now we come to the actual methods that really change something. First thing, always lockup. Yes, honestly, we could have called it deposit. I didn't change it because, in the beginning it was lock pools and there was the lockup. We could call it deposit, but in the end it doesn't matter. It's just a name, right? So I kept it. Now, if core team might decide to change it to deposit or whatever. So we have the lockup. You send in funds. It's non-reentrant, so you can't. It's safe against reentrancy attacks. The function itself, in my opinion, is not or doesn't have any flawed, can't be exploited with reentrancy, but it's still better safe than sorry. So it's saved with or is secured with the reentrancy card. Generally, if you want to lock up funds, we first check, is the current total value locked plus the funds still below the investment cap? If it's bigger, revert with an error. If you try to send in no funds at all, revert, because we don't want to add empty investments. Then, if that's fine, we transfer the funds that you want to send in the coin. So the coin is transferred, which is in our case the DUSD, from the sender to us. This amount of funds transferred. If the funds are not approved or anything, this fails and the whole thing gets rewarded. But now we know we have the funds on our side and we can update our internal states. This is important for reentrancy attacks, because otherwise if you update the state and then transfer the funds, it might be that you have some error there and might re-entrant and add states without the funds ever getting added. Now the investments we add to this array, a bond entry with those funds locked up until current timestamp plus lockup period, current rewards per deposit to save that in the initial rewards per deposit, and claimed rewards is 0. Now this is there, the data is there, total invest gets increased by the funds, and the batch ID that we have is now the last index in this investment array, because it was already added, so it's -1. And now we mint this new NFT with this batch ID, token ID of the NFT equals batch ID or index in our investment, mint it to the sender, and emit this event that everyone who is watching knows a new deposit was added. And that's it. Lockup done, everything updated, we are fine. Now to the other side, if you want to withdraw, we again have reentrancy guards, and the batch needs to be owned by the owner, by the sender, so that he can withdraw. And because of this reentrancy guard, and because we use it in two methods, we have the withdraw batch as an internal function. It's down here, which is internal and directly does the stuff. Here we don't have any reentrancy guard or owned or anything, because it's internal and must only be called by functions that make sure that it's done. As you see, it's called in those two functions. Here we have the entrancy guard, here we have the entrancy guard, here we make sure that it's owned, and here we iterate only across over the owned stuff. Additionally to that, the withdraw batch only sends the funds to the owner. So it's not directly sending it to the sender of the message, it's sending it to the owner. So that's always, you get the funds back to the owner. The withdraw all my available batches is again just a convenience stuff. If someone wants to do that, it's easier and saves a bit in gas if you do it at once. So you again take all the tokens from the owner, iterate over them, get the batch ID, get the bond, and check if this batch can be withdrawn. We do that here because if we call that, in here he has also the check that it's only done if it's possible, because we need it in this case. So only call that if it is withdrawable, otherwise we would get an error here and are out. So we need to check and only call that for the ones that are possible. Withdraw that, everything that is withdrawn is then, we are just checking that and all the updates happening in here. So let's look a bit into that function. First thing, get the investments out, or get the batch ID, check if it can be withdrawn, exit criteria. If it's not the exit criteria triggered and not above the lockout, then error, revert and everything. If it's already withdrawn, if it's empty, you can't withdraw anything. So again, an error. Then, and that's also important, if there are still available rewards on that batch, first claim those rewards, send the rewards to the owner, and then withdraw, because otherwise those rewards would be lost, and we don't want users to lose their rewards. So let's do it like that. And then everything is done, claimed, and we are ready to withdraw. We get the withdrawal amount because we need it later on. Add the total withdrawn. So we update the states and then transfer it out. It's always with the reentrancy. If you get tokens from someone, first get the tokens in, then update the state. If you have to send tokens out, first update the state, then send the tokens out. So you always make sure that when you change the state, it's still in your best way of the token balance. So you change the balance before or after in a way that it's always beneficial for you if you cut up in between. And this also always means if I send something out, I first update the state that I say, okay, I own less tokens now. I already gave it to you basically, and then send it, and not the other way around. So here we update, say, okay, this is withdrawn, the token is burned, and now transferred out, because it should anyway, if all goes, if there's no attack or exploit trying or anything, it's always done at once, so it's always fine. But if someone tries a reentrancy attack or something, we first update the state. So if there would be an reentrancy, for example, in this case, if there would be a reentrancy, we first update that. So if we get in here before we send the funds, the amount is 0, we get in and we get an error because the amount is already 0. If we would send the funds before we set the amount to 0, we send the funds out, then the reentrancy goes in again, and the amount would not be set to 0, we would send the funds again. And that's a risk of the reentrancy. So reentrancy safety, on the one hand, we have the reentrancy guard in general, but also we have the order correctly. And at the end, send the transfer the funds to the owner of the batch, the amount that is withdrawn. That's the old withdrawal case. Now the rewards case is basically here. We say, okay, you can claim rewards for one batch. You can only claim rewards for your batch. In general, it wouldn't matter because we anyway send it out to the owner. But I don't want anyone else to trigger the payout for my rewards because for tax reasons or whatever. So only the owner of the batch is allowed to claim the rewards for this batch. And when you claim the rewards for the batch, we calculate the available rewards. As I said, most important thing, that this function is correct. And we claim them, or we calculate the available rewards. If this is 0, no rewards, and out. If it's fine, get the bond entry that we want to update. Again, update the state, then transfer the funds. We update the claimed rewards that we say, okay, that amount is now claimed, the total in our overall state, and then send the funds out and emit the event that this owner claimed this batch ID, the rewards. Again, we have a convenience function here to claim all rewards for an address for the sender. Take the sender, go through all the tokens that he has. If it's the owner, get the available rewards. If there are rewards claimable for this stuff, directly do that. Update this entry, already emit the rewards, and if everything is fine. Otherwise, if there's no rewards to claim, reward it. Otherwise, send funds out. Here, it's a bit different to the withdraw. I mean, the withdraw, we send it directly in here and call the function. Here, we accumulate it together and send it at the end. Honestly, there is no real difference between the two. I think we could do it directly here. Too, we could call it here. But in an earlier version, I think that's just historic reasons, because in an earlier version we wanted to have one event for all the rewards, and now it's anyway spread up, so not a big difference. Important is that we send the funds after the status is updated. So that's just, again, this convenience method. And the last thing is adding the rewards in. And as we had in the graphics before, it's also not much to do here. Someone says, I want to add that amount of rewards. First, we need to make sure that we have a TVL, because otherwise we can't calculate this rewards per deposit. And then transfer the funds in. Again, first transfer, then update from the sender to us the amount. Total rewards is updated. Rewards per deposit is updated. Again, here we have this digits stuff again, because if you divide 18 digits number by 18 digits number, you would end up with a 0-digit number. So we first have to increase the digits on this one to say it's a 36-digit number now, and then divide it, so we end up with a nice 18-digit number. And this is added to the rewards per deposit. The event is emitted with the current TVL and everything, and then the last rewards block is saved, because with this you know the blocks since the last reward, and you can extrapolate the TVL on that. And that's it. That's all there is about the code. I mean, okay, 1 hour in or something. Sorry for that, but that's basically the logic and the review of all the stuff that's happening in this contract. As I said before, we also have this nice graphic, this nice bond. It's also, if I zoom on it, it's also updating, it's also or animating. And we also have, as you see here in this graphic, in the image, the amount that's locked in this NFT. So this changes, this is depending on the smart contract. With all you know now, you now know where this data comes from. This comes from the investments array, and we also have this here in the trades, where we have the amount locked until, also the available reward. We didn't put the available rewards into the image because some marketplaces might cache the image, and that would be bad if you have the rewards on the image and then someone wants to buy that and thinks there are a lot of rewards on that, but they are already changed and claimed. So it's just here that it's available rewards because this is updated frequently. And with the category and the duration, 1 year in this case. And this data is all coming directly from the smart contract. This is not saved in any file storage somewhere. This is directly from the smart contract. And also the SVG is directly from the smart contract. By the way, shout out to Ian for creating this. I don't know how he did it. I don't understand SVGs or anything, but I think it looks great. And it's crazy to have animations in the SVG and everything. So big thanks to him for supporting us with that. And now let's look how this is done in the smart contract so that we get this data out. As I said, it's directly here in the bonds. And in general, we have on an NFT, the smart contract provides this function token URI, which is basically just a method that gives you usually a URL that you put into the browser and where you get the metadata. And the metadata is just a JSON file. But browsers also allow, or web allows us to encode data directly into this URI, so that we don't tell the browser get it from there, but it directly gets it from the data. And that's what we do here. The require owned is just that we make sure that this token is actually owned by someone, so it was minted and is not burned. So that's just a safety that we don't get invalid data somewhere, and then we build the metadata. And building the metadata is just a bit of get the batch data from the manager, because we know the manager. So we get the data, so we know what data we need to put in there, and calculate the years, calculate the rewards, get the category and everything. But then it's basically concatenating strings. And the result is an URI that tells you this is a data from the type JSON, and it's base64 encoded data. And this encoded data is a JSON format. As you see here, it's with all the quoting and everything, but it's just a JSON with the name, and the name is generated dynamically, the description generated, where we have here the amount from the data that we got, the DUSD bond data, the amount. This two-digit string is just that because it's an 8-digit number and you don't want to have 8-digit number all the time. So we have the 2-digit number converted from 8-digit to 2-digit. Just a small helper in there. And then we have the image, which is again a UI, which is a data and SVG image, base64 encoded, and we build it up there. And for this, we need this base64 library that we can encode base64 data. And then we have the image, and then we have those attributes based on the common convention on how to add attributes so that the marketplaces can read them, with the trade type, with the amount, where we put it in, we have the locked until, where we get the date, and we have the available rewards, the category, and the locked up period. And that's it. Just concatenate a JSON data, base64 encoded, put it in there, and return it out. And the other thing, which is a bit more complex for me, say it this way, or in my opinion, with the SVG, because I have no clue how Ian did that, but basically, again here, we return a text file that we base64 encode, which is an SVG, because an SVG is just an XML file in the end. And it's an SVG with all the data, and then you have the path in there, you have the font, you have the style, you have the class of the symbol, the path of the symbol, this DUSD symbol. You have the curve, where it moves with the animation and everything. And here we can add into the string of this XML, we can add the amount, we can add the locked periods. And here we also have, and that's what we need this timestamp library for, the date time stuff, where we format the timestamp of this locked, the DUSD locked until. So it's easily formatted. And then with just the different categories, have different NFTs, the normal, the gold, the black, and the iridescent version, which is just for eye candy basically. But yeah, NFTs, it's nice to have good looking images for the NFTs. So that's it. That's how you create dynamically generated metadata and images directly out of the smart contract. Nothing saved anywhere. I mean, except for the font. I think it's a Google font, font family. It's the Google font that's added from here, where we say, okay, import fonts from the Google, the Montserrat, but that's it. Nothing else comes from anywhere outside. All the data, all the image, everything generated dynamically right in the smart contract. And that's it. Camera is off. That's it. 1 hour in. If you made it till here, congrats, thanks. I hope that helped. Again, please go to the repository, leave your comments, and help us get this thing reviewed, bulletproof, on the road. In my opinion, it's ready, it's done. There should be no flaw whatsoever, no issue whatsoever, but more eyes, the better. So please look at it, review it. Also give a thumbs up on the final review pull request, because then we know that more people looked at it and have a better confidence in the whole thing. So with that, if there are any questions, leave a comment and leave a like. You know how it goes. And I hope we get this thing on the road soon. And yeah, we will likely look at it, and I will analyze the whole situation once we have new data. So with that, see you in the next video.